I don't think I'm doing anything differently.
I don't know if I'm doing anything differently either.
I don't know.
We're experimenting.
Yes, apparently.
You see what happened? As soon as I picked this up and erased it, then it gave me the rest of the line that wasn't there before.
Erase back, drag it up.
Okay, for the third time. So we're going to give ourselves a visual image of how to do this. We go -5, 6, and this doesn't have to be exact, just approximate to give yourself an idea of what this looks like. Then we have Q, -4, -2. Then we have R is 4 and -1. And we have S at 3, 7. And we can give ourselves an idea of what this looks like. And now we're ready to use these letters to come up with some thoughts on what type of figure this is. Now, I think the easiest way is to use the slopes. If the slopes of the opposite are the same, then these are parallel. If the slopes are different, they aren't parallel. Okay? So we're going to first check the slopes to see if the opposite sides are parallel. So I'm just going to pick out two. I'm going to pick out PQ and SR and see if they are parallel. And I'll do that by using the slope formula, which is y2 minus y1 over x2 minus x1, and that is the slope. So in using PQ, it's going to be 6 minus a -2 over -4 minus -4, which is 8 over -1, which is 8, negative. Finding SR the same way, we end up with SR. SR is also -8. Okay, that's the slope of SR. So now we know that these two are, in fact, parallel. We use the same concept with PS. We go 7 minus 6 over 3 minus -5, which is 1/8. And so the PS is 1/8. And we do the same thing with QR. And as we find the slope with QR, we also get 1/8. So this one is 1/8. So now we have both pairs of opposite sides have the same slope. So we know that it is a parallelogram. Okay. Next thing is we look at the consecutive angles, like these two angles, the two that are consecutive. If you take a look at the slopes of consecutive angles, if these form right angles, if these two slopes form right angles, then their product is a -1. So in this case, -8 times 1/8 does equal -1. Therefore, the lines are perpendicular. So now we know that these angles, all four angles, are right angles, which makes this a rectangle. Okay. Now we need to see if it is a rhombus, and if it is, it's also a square. Now there's different ways, but I think the easiest way is to take a look at the diagonals. If the diagonals are perpendicular, then you have a rhombus. So as we find the diagonals here, we have the diagonal PR has a slope of -7/9, and QS has a slope, using the same methods that we used before, has a slope of 9/7. So in this case, to see how these two compare, if we multiply them together, -7/9 times 9/7, in this case that does equal to -1. So therefore, it is a rhombus because the diagonals are perpendicular. This gives it a rhombus, if I can spell that correctly. So now we've got a rhombus. Boom. So now we have something that's both a rectangle and a rhombus, and something that's a rectangle and a rhombus is a square. So the best name is a square, but this figure is all four. Any questions?